All right, in lab 2, you're going to be measuring the speed of sound. And to do that, you're going to have a couple of videos where you watch a group of band members. They're spaced 10 meters apart, with Emma being the first person who is right next to the metronome. So they'll have the metronome sounding, and they're going to try to clap in sync with it. And as you watch that video, you're going to notice that at some point, they start to not clap in sync with each other. So what you're going to do is you're going to end up measuring the time it takes the second person to make the first clap, then the time it takes a third person to make the third clap, and so forth. And they're all 10 meters apart. So basically you're going to get the time at which sound reached each of those students every 10 meters. And obviously, Emma, who's number 1 and closest, is going to be our, she's going to be our 0 point. So we're going to create a column of position in meters and time in seconds. And the variable for position can be x, and the variable for time can be t. And so at 0 position, there's 0 time. And then as we press play here, what I'm going to do is I'm going to play this, and when the second person claps, I'm going to record that time. So at 10 meters, the time was 0.24167. I'm going to rewind it, and I'm going to time it for the third person at 20 meters. And that is at 0.2667. So at 20 meters, it's 0.2667 meters, seconds. And I'm just going to keep doing that for each one. So now I'm going to do the fourth person. And that's at so at 30 meters, it's 0.31125. So everybody will have slightly different numbers, so you can't really just copy my numbers. But you're going to be able to make a graph now of position versus time. And so remember that you're going to put position on the y-axis, and you're going to put time on the x-axis. And you are going to be able to insert a linear fit. It should be linear. So that means you go to curve fits and you click on linear. And it's as you get more points here, because you'll have 8 points or 7 points, you'll have a better feel for the slope of this. Because remember, a linear position graph, and let's go ahead and title it Position versus Time. The slope of this graph is going to be the speed of sound. So you're going to want to be able to get the linear fit parameters, and the slope is going to give you the speed of sound. So we're going to compare that to what the speed of sound is on a 70-degree day, which is 330 meters per second. So this value here is not accurate because I don't have all my points in. But you will get some kind of value, and that value will be your value of the speed of sound for that location with those conditions for the medium that it's traveling through. And then you're going to compare it by finding the percent error. And so remember, the percent error is your experimental value, so your slope, minus the value you're comparing it to, divided by the value you're comparing it to. And then you multiply it by 100 to get the percent, and you just take the absolute value of it. So that's what you're going to be doing in this lab.